Hello students, and welcome to the first time of Mrs. Bieber teaching you from her house. Hopefully it goes well and you are able to learn everything that you are going to when we were together. So a couple of things that you need to be aware of before we start. The first important thing that you need to be aware of is that this is an Edpuzzle. All that means is that at periodic places on this video, it will stop and you will be required to type in answers to some questions that Mrs. Bieber has. That's just so that I can check your engagement with the video and make sure you're not just tuning out on me here. Also, this video might be a little bit of a long one, and the reason for that is because normally we would be together for about an hour and a half for math time. And because we aren't actually in person face-to-face, Mrs. Bieber still needs to make sure that I can cover the same amount of content. I don't want you guys to get behind just because we can't be together. That wouldn't be very fair to you. So let's go ahead and get started. We are going to be talking today about representing the place value of whole numbers using powers of 10. We are going to mainly talk about using whole number exponents to show powers of 10. The second learning goal is something that we will cover mainly tomorrow. Let's get started with some mental math. So the first thing that we're going to talk about is exponential notation. This is an important vocabulary term to talk about and to really delve into pretty deeply. Right over here, you can see that there is an example. And my example is 10 to the third power. If I look at that example, we have two parts of this exponential notation. We have something called the base, and that's the 10. That's the big number there on that example. We also have something called the exponent, and the exponent is this tiny little number at the top. What the base is and what the base does is it tells us the number that is going to be repeatedly multiplied. Oh my goodness, that's a lot. Let's break that down. The base tells us the number that is going to be multiplied repeatedly. That means multiplied more than one time. The exponent tells us how many times the number is multiplied. So in this example, with 10 as our base, we know that the number 10 is going to be multiplied 3 times. So it's going to be 10 times 10 times 10. That is also a power of 10 because it has 10 as a base. That was something Mrs. Bieber forgot to mention. So, for example here, if we have 10 to the first power, that means that the base, which is 10, is going to be multiplied one time, just once. And so there's nothing else here. It also equals 10 because it was only being multiplied once. If I have 10 to the second power, that means that 10, our base, is going to be multiplied 2 times. 10 times 10. That equals 100. If I have 10 to the third power, that means our base, 10, is going to be multiplied 3 times. 10 times 10 times 10. That equals 1,000. And let's take a notice here at our zeros at the end of our problem. How many times for 10 to the second power? How many times here was 10 multiplied? That's right, 2. How many zeros do we have in our answer to the problem? Let's count them. We have 1, 2. 10 to the second power. Multiply 10 2 times. 2 zeros in the answer. Curious. Let's look at 10 to the third power. We are multiplying 10 3 times. How many zeros are in this answer? Let's count. 1, 2, 3. Oh, 10 to the third is 10 3 times, and there's 3 zeros at the end. Guess what? That pattern works every single time. Take a look at my table right here below. We have 10 to the 6th power. 10 to the 6th. That means that we are going to multiply 10 6 times. Look, 10 times 10 times 10 times 10 times 10 times 10. Then in my answer, it also means there are going to be 6 zeros. Let's count. 1, 2, 3, 4, 5, 6. See, 6 zeros. Now, here's something that you might not realize yet. This only works with the base of 10. This does not apply if the base is something else, like 5 to the second power. There are no zeros in the answer of 5 to the second power. It doesn't work like that. It only works, and this pattern can only be generalized when 10 is our base number. Let's try another one. Let's say that I have 10 to the 10th power. That's right, it sounds like a lot, but all it actually is going to be 10 times 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 10. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm still at 8. Times 10 times 10. I had to write 10 a lot of times. And you know what? It's hard to write 10 out that many times. It takes a while. It's much easier to say 10 to the 10th power. That's part of the reason why we have exponents, to save ourselves a little bit of time. 10 to the 10th power means 10 is multiplied 10 times. How many zeros do you think will be part of this answer? If you said 10, you're right. The answer to 10 to the 10th power is 10 billion. And that's why 10 to the 10th and using exponential notation can be so helpful to us, because it allows us to express really big numbers in just a little space. Let's continue to look at this, because some numbers are actually represented as the product of a power of 10 and another number. What does Mrs. Bieber mean by that? Remember, product is the answer to a multiplication problem. So I have a number or a problem like 3 times 10 to the second power, or 10 squared. This means I can write this in several different ways. I could write it as 3 times, and then I can write out 10 to the second power, or 10 squared, by doing this, 3 times 10 times 10. Or I could actually solve the 10 squared problem, this part, the part in parentheses. That means that I would be doing 3 times 100, because remember, 10 squared is equal to 10 times 10, which also means that we have 100, 2 zeros on the end. What is 3 times 100? This one should be rather easy. Yes, you're right. It is 300. So 3 times 10 squared is 300. Now, you might notice this. If I know that there are 2 zeros on the end of that power of 10, I can just take this 1 and this 3 and multiply them. 1 times 3. And then I know that I should have 2 zeros on the end because we multiplied it by a power of 10 that had 2 zeros on it to get me 300. This can also work in reverse. So I'm going to look at 65 million. I know that 65 million, the only numbers here that aren't zero, is 65. I can take 65 and I can multiply it by a power of 10. What power of 10, you might ask? Well, all you need to do is count the number of zeros, and that's the power of 10 that you would use. So 65 million here, you can see that there are 6 zeros on the end. So all I would do to change that into a product of a power of 10 is write the numbers that are not zero, which is 65, and then count the number of zeros, which is going to be 6. So that means that I have 65 times 10 to the 6th power. It is equivalent to 65 million. Let's do a little bit more work with this. Mrs. Bieber would like you to have a pen and a pencil and a piece of paper here. I'm going to give you a couple of seconds of think time to try to answer the question, and then Mrs. Bieber is going to give you the answer. We're going to work through the first couple together, and then I'm going to release some of that responsibility to you to answer. So, if you haven't already, pause the video and go get a pencil and a piece of paper. Do 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 do. Oh, good. You should be back by now. I didn't even have to make it through the whole song because you paused the video. So here we go. Looking at 3 times 10 to the second power. We have 3 times 100. They are equivalent because all I did was take this 10 to the second power and change it into standard form, which is 100. 3 times 100 becomes then very easy. I can use basic facts to know that 3 times 1 equals 3, and then I can count my zeros on the end. And I have 2, so I can put 2 zeros on the end. Let's take a look at this next one. 7 times 10 to the 9th power. What is 10 to the 9th power written in standard form? Remember, that's the way that we normally see these numbers. Write that down on your paper now. Let's see. You would have a 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you wrote down 1 billion, you would be correct. 10 to the 9th power is 1 billion. 7 times 1 billion, and I know my zeros don't look super great. I'm sorry about that. It's the best I can do with my finger as a tool to use to write. I can do basic facts. My basic facts tell me that 7 times 1 is 7. And then I can just put my 9 zeros on the end. So my answer to this problem is 7 billion. Let's take a look at this next one, and then Mrs. Bieber is going to give you time to do the rest of them on your own. So I have 3 times 10 to the 4th power. If we write this out in more standard form, we would have 3 times what? What is 10 to the 4th written in standard form? Let's think about that. It's a 1 with 4 zeros after it. A lot less than 1 billion. This time it's only 10,000. See if you can solve that problem now. You should have gotten 30,000 as your answer. Great job. If you didn't, consider what did you do wrong? Where did you go wrong? Now, look at numbers, pause the video, and see if you can solve numbers 4 and 5 on your piece of paper. Great job. So, here are the answers that you should have. Remember, check your own work and ask yourself, if you went wrong, what did you do? So, I'm going to start with 25 and writing this out in more standard form. Then I have 10 to the 3rd. I know 10 to the 3rd is a 1 with 3 zeros after it. So that means 1,000. I'm looking at basic facts and I see 25 times 1 is 25, and then I can have 3 zeros after that. So that means my answer is going to be 25,000. Now, let's try this one backwards. I know my answer is 93 million. And if I think about that, it's going to be the standard form is going to be 93 times 1 million. And if I think about that, I know that using powers of 10, I can have 93 times 10, and then I need to change that 1 million into a power of 10 using exponential notation. So I can count my zeros, 1, 2, 3, 4, 5, 6, and so it will be 10 to the 6th power. How many did you get right?